So we defined a single ply, we defined the stresses and strains and the corresponding stiffnesses that relate stresses and strain in a single ply, whether the axis system is aligned with the fibers or is not. Okay, now we are ready to build up and create a whole laminate and put all these plies together. So what I'm interested in is if I put them all together and I apply a force, let's say a tensile force first, I need to know what is the equivalent stiffness of that structure. So I have a laminate which consists of different layers. Obviously, I have less plies here than there, but pay no attention to the man behind the curtain. The whole idea is I apply a tensile load, and I need to determine the stiffness of this as a function of the stiffnesses of the individual layers. And this is where strain compatibility comes in. Basically, all I know is that if I grab one end and I pull on it, all of the layers will move an equal amount. Whether the stiffness is 10 or the stiffness is 1, they are all forced to move an equal amount. So the amount by which they move divided by their original length gives me the longitudinal strain. And if the amount by which they move is the same for all of them, they all have the same strain. So if they all have the same strain, if I number these 1, 2, 3, and so on, the strain in the ith layer is the same as the strain, the constant strain for any of them. So EA for applied strain. Now the strain in the ith layer is the force in the ith layer divided by the E of the ith layer times A of the ith layer. Because stress divided by force divided by area is stress, divided by Young's modulus gives me the strain. So all these are equal to my total applied force. Let me call it F total for divided by the E of the laminate times the area of the laminate. By the way, the area of the laminate is just this cross-sectional area here because I'm applying the force in this direction applied on this surface. So at the same time, I know that summation of Fi equals F total. All the forces in all the layers have to, by force equivalence, add up to the total force. So on the one hand, I know that the ith force relates to the total force through this relationship, and on the other, I know that the summation of all the forces for each of the plies is equal to the total force. That means I can solve for each of these forces to do an example to make it easier. Let's say I only have 2 plies. Then I know that F1 plus F2 equals the total force. I also know that F1 divided by E1 A1 equals F2 divided by E2 A2 equals F total divided by E of the laminate A of the laminate. So if I take this relationship and substitute for F2 here, I get that F1 plus F2 is F1 E2 A2 over E1 A1. Right, so plus F2 equals F total. So I substitute for F2 from this relationship, F1 times E2A2 over E1A1 will give me F2. So I can solve for F1 is F total divided by E1A1 comes out E1A1 plus E2A2, and it's multiplied by E1A1. So the force on in the case of two plies, the force in one ply, ply 1, is just the total force times the EA of that ply, product of E times A divided by the sum of the EAs. So in general, I can generalize this and simply say that if I have I plies, Fi is equal to EI AI divided by the summation across all plies of EI times the total force. So this allows me to find the individual force in each ply. Now, what is my total EA? If I know that F total, let's see, I want to say that epsilon applied is F total over E laminate, A laminate. So if I solve for E laminate, A laminate, I get F total divided by epsilon applied, but epsilon applied is also any strain of the different plies, so which is equal to Fi over EI AI. So if I combine these, we can show that there's a relationship that will cancel these, and E laminate A laminate is the summation of EI AI. And if you cannot follow the missing steps, you can let me know. But in general, because the strains are the same for each ply, the total or the equivalent E times A, membrane stiffness as it's called, for the entire laminate is the sum of the EAs. But what are the sum of the EAs now? If I replace my E with my QIJs, that because we are using Q because it's the convention for plies, then I can write that the EA for the ply I is the Q, corresponding Q times A, the corresponding area for the ply I. And if the EA for the laminate is the summation of the EAs with